which one set is of dependent variables and the other set is of independent variables. In a displacement time graph, displacement is a dependent quantity taken on the y-axis and time is taken on the x-axis as it is independent. If the position of an object changes with time, it is said to be in motion. If an object has equal displacements in equal intervals of time, then the graph is a straight line inclined with the x-axis, which represents uniform motion of the object. If the graph is a curve, it represents non-uniform motion. The slope of displacement time graph gives velocity of the object. We will go through this in detail after a short interactivity. Distance time graphs. Plotting distance against time can tell you a lot about motion. Let's look at the axes. Time is always plotted on the x-axis, bottom of the graph. The further to the right on the axis, the longer the time from the start. Distance is plotted on the y-axis, side of the graph. The higher the graph, the further from the start. If an object is not moving, a horizontal line is shown on a distance time graph. We can see that the time is increasing to the right, but its distance does not change. It is not moving. We say it is at rest. If an object is moving at a constant speed, it means it has the same increase in distance in a given time. In the graph we can see that time is increasing to the right and distance is increasing constantly with time. This means the object moves to a constant speed. Constant speed is shown by straight lines on a graph. Velocity time graphs. Velocity time graphs are also called speed time graphs. Speed time graphs look much like distance time graphs. Time is plotted on the x-axis. Speed or velocity is plotted on the y-axis. A straight horizontal line on a speed time graph means that speed is constant. It is not changing over time. This graph shows increasing speed. The moving object is accelerating. This graph shows decreasing speed. The moving object is decelerating. This is a velocity time graph of an object in non-uniformly accelerated motion. Equations of motion by graphical method. The three equations of motion are v is equal to u plus at, s is equal to ut plus 1 upon 2at square, 2as is equal to v square minus u square. Where u is the initial velocity of the object, which moves with uniform acceleration a for time t. V is the final velocity, and s is the distance traveled by the object in time t. This equation describes the velocity-time relation. This equation represents the position-time relation. This represents the relation between the position and the velocity and can be obtained from these two equations. Let us go through them one by one. Equation for velocity-time relation. Consider an object moving with a uniform velocity u in a straight line. Let it be given a uniform acceleration a at time t is equal to 0, when its initial velocity is u. As a result of the acceleration, its velocity increases to v, final velocity in time t, and s is the distance covered by the object in time t. The figure shows the velocity time graph of the motion of the object. Slope of the vt graph gives the acceleration of the moving object. Thus, acceleration is equal to slope, which equals ab, which equals bc upon ac, which is equal to v minus u whole upon t minus o, where a is equal to v minus u whole upon t. This equals v minus u equal to at. V equals u plus at, which is the first equation of motion. Equation for position-time relation. Let the distance traveled by an object is s in time t and acceleration a. We can see that the distance traveled by the object is obtained by the area enclosed within. Therefore, distance traveled s is equal to area of the trapezium ABDO, which equals area of rectangle ACDO plus area of triangle ABC, which is equal to OD into OA plus 1 upon 2BC into AC. Putting the values, we get T into U plus 1 upon 2 into V minus U into T Solving further, we get ut plus 1 upon 2 into v minus u into t. Now from the first equation we know that v minus u is equal to at, or we can write v is equal to u plus at. Therefore, s is equal to ut plus 1 upon 2 at square. This is the second equation of motion. Equation for position-velocity relation. The third equation will be obtained from these two equations. From the velocity time graph, distance travelled s is equal to area of the trapezium OABT. This is 1 upon 2 into b1 plus b2 whole into h, which is equal to 1 upon 2 into OA plus BD whole into AC. Substituting OA by U, BD by V and AC by T, we get S is equal to 1 upon 2 into U plus V whole into T, equation 1. But we know that A is equal to V minus U whole upon T, or T is equal to V minus U whole upon A. Substituting the value of T in equation 1, we get V square minus U square is equal to 2AS. 2AS is equal to V plus U into V minus U. V plus U into V minus U is equal to 2AS. By using the identity A square minus B square is equal to A plus B into A minus B, we get V square minus U square is equal to 2AS. This is the third equation of motion. Uniform circular motion. Uniform circular motion describes the motion of a body traversing a circular path at a constant speed. The distance of the body from the axis of rotation remains constant at all times. As an object moves in a circle, it is constantly changing its direction. Merry-go-round is an example of uniform circular motion. Satellites orbiting our Earth, artificial satellites or our moon, have motions that are very nearly uniform circular motion. The planets that orbit our sun have motions that are very nearly uniform circular motion. Did you know? Sir Isaac Newton is one of the most influential scientists of all time. He came up with numerous theories and contributed ideas to many different fields, including physics, mathematics, and philosophy. Born in England, Isaac Newton was a highly influential physicist, astronomer, mathematician, philosopher, alchemist, and theologian. Newton's 3 laws of motion relate the forces acting on a body to its motion. Johannes Kepler helped lead a scientific revolution in the 17th century with his amazing work in the field of astronomy. Among his many contributions were the 3 laws of planetary motion. Summary. Let us summarize what we have learned. Motion is a change of position. It can be described in terms of the distance moved or the displacement. The motion of an object could be uniform or non-uniform, depending on whether its velocity is constant or changing. The speed of an object is the distance covered per unit time, and velocity is the displacement per unit time. The acceleration of an object is the change in velocity per unit time. Uniform and non-uniform motions of objects can be shown through graphs. The motion of an object moving at uniform acceleration can be described with the help of 3 equations, namely V is equal to U plus AT, S is equal to UT plus 1 upon 2 AT square, 2AS is equal to V square minus U square, where U is the initial velocity of the object, which moves with uniform acceleration A for time t. V is its final velocity and S is the distance it travelled in time t. If an object moves in a circular path with uniform speed, its motion is called uniform circular motion.